Now we will find the centroid of region bounded by function y equals x squared and function y is equals to 8 minus x squared. This is what it looks like, the graph. First, we will find the points of intersection. I have already solved it. The points of intersection is -2 and 2. Now we will solve the area. Area equals to integral of 0 to 2 multiplied by the first function, the top function, and minus the bottom function. 2 is equals to 2 integral of 0 to 2 multiplied by x 8 minus 2x squared dx. Then 2 multiplied by 8x minus 2x squared over 3 2 0, and then we plug in the 2 and the 0. This equals 2 minus 16 over 1 minus 16 over 3 minus 0 is equals to 2 multiplied by 48 over 3 minus 16 over 3. The area is equals to 64 over 3. And now we will find the value of x bar x bar is equals to 1 over a integral of -2 to 2 x multiplied by f of x minus g multiplied by x dx. So 3 over 64 integral of -2 over 2 x multiplied by 8 minus x squared minus x squared dx. So 3 over 64 integral of -2 to 2 x multiplied by 8 minus 2x squared dx equals 3 over 64 integral of -2 to 2 8x minus 2x squared dx is equals to 3 over 64 integral of -2 to 2 multiplied by 8x to minus 2x cubed dx is equals to 3 over 64. This is integrated part. 4x squared minus x to the fourth over 2. And now we will plug in the 2 and the -2. 3 over 64 multiplied by 16 minus 16 over 2 minus multiplied by 16 minus 16 over 2. And now this is the answer. 3 over 64 multiplied by 0 is equals to 0, and the x bar is equals to 0. And for the y bar, we will solve it. 1 over a integral of this is the formula, integral of a to b 1/2 times 1/2 and multiply the f of x, the first function, and minus the second function or the bottom function. 3 over 64 times 1/2 integral of -2 to 2 times top function and the minus bottom function. 3 over 128 integral of -2 to 2 multiplied by 64 minus 16x squared plus x to the fourth minus x to the fourth dx. 3 over 128 integral of -2 to 2. This is the multiplied by 64 minus 16x squared dx. 3 over 128 multiplied by 64x minus 16x cubed over 3, and this is the integrated part. This is integrated, and we will plug in the 2 and the negative 2. 3 over 128 multiplied by 128 minus 128 over 3 minus negative 128 plus 128 over 3, and negative, no 3 over 128 multiplied by 256 minus 256 over 3, and then this is the simplified part, simplified answer. 6 minus 2 is equals to 4. This is the y bar. And now we will calculate the inertia using parallel axis theorem. Supposed to be, we have 4 blocks. Each block has a mass of 4 kilograms. They are equally 5 meters away from the axis of rotation. So now we will solve it. The inertia of the system passes the center of mass equals sum of individual moments of inertia of each of in this system. So times mr squared equals 4, the equivalent of all blocks, times 5 meters, the distance between the distance of all the blocks of the axis rotation in the axis rotation. Then to get the inertia, the mass, we will multiply it by 4. So 5 meters squared is 25, times 4 is 100. 100 times 4 is 400. So it is equals 400 kilograms times meter squared. So we will move the axis of rotation 9 meters away. To get the new inertia, these two blocks is 4 meters away from the new axis of rotation. So 2 times 4, then this is the distance, 4 meters squared, plus then these two blocks, it is 14 meters away from the axis of rotation. So it is 2 times 4, this, times 14 meters, the distance squared. So is 128 plus 1568 is equals 1696 kilograms times meter squared. So we will try to use parallel axis theorem. I nu is equals to I, center of mass, the old one, plus md squared equals 400, the old inertia, mass of inertia, 400 plus 16 is 4 plus 4 plus 4 plus 4, the blocks, times 9, the distance squared, equals of 1696. So it is the same one. It's also the same. And now we have composite area, and we will solve the area of shaded region. First, we will solve the rectangle part here. Second is we will find the area of the circle, 2 circles. And third is we will subtract the area of rectangle and the area of 2 circles. First is we will solve the area of the rectangle. A equals base times height. A equals 18, the base, times 9, the height of the rectangle. Yeah, 18 times 9 is equals to 162. And now we will solve the two circles, the area of two circles. A equals 2 pi r squared. This is the formula of the circle, area of the circle. Equals 2 times pi times 4.5, the radius, the half of the 9 meters. 4 times 5 squared. The circle's area is 127.24 meters. Now, we will subtract the area of the rectangle and the area of the two circles. 162 minus 127.24. It is equals 34.76 centimeters squared. Now we will solve a problem about mass moment of inertia. The pendulum consists of 84 kg disc A, a 2 kg circular disc B, and a 4 kg slender rod. Determine the radius of hydration of the pendulum about an axis of perpendicular to the page and passing through point O. Solution. Mass moment of inertia about an axis through O. The mass moment of inertia of each rod segment and disc segment shown in figure A about an axis passes through the center of mass can be determined using inertia G equals 1 half MILI squared and IG is equals to 1 half MIRI squared. This is the solution. IO equals the sum of multiplied by IG times I plus MDI squared equals to 1 over 12 multiplied by 4 multiplied by 1.5 squared plus 4 multiplied by 0.25 squared plus 1 half multiplied by 2 times 0.1 squared plus 2 times 6.6 squared plus 1 half times 8 times 0.2 squared plus 8 plus times 1.2 squared, and the answer is equals to 13.41 kilogram times meter squared. The total mass is you add the 8 kilograms, 2 and the 4 kilograms. It is equals to 14 kilograms. The radius of gyration is the formula of radius of gyration is KO is equals to square root of inertia O over M is equals to square root of 13.41 kilograms point M times M squared over 14 kilograms. It is equals to 0.979 meters. And now we will solve a problem about product of inertia. Determine the product of inertia of shaded area with respect to the x and y axis. It has illustration here. This d I xy. This is the formula. Is equals to di x prime y prime plus dA x bar y bar times y bar is equals to, this is the solving, 0 plus 2y 1 half dy multiplied to y 1 half times y. It is equal to 2y squared dy. Product of inertia performing integration. This is the formula for us to get the answer. Ixy is equals to integral of di xy is equals to integral of 0 to 1 inch 2y squared dy is equals to 2/3 y cube and 0 to 1. If we will put this into the equation, the 0 and 1, the answer is 0.667 quadratic inches.